Hello everyone and welcome back. My name is Mr. Kowald, and in this video I'm going to be going over standard molar entropies and the third law of thermodynamics. So in my previous video I talked about what the definition of standard molar entropies is, and the question was, well, once we have that definition of what a standard change in entropy and how that is the difference between the entropies, the molar entropies of your reactants or your products minus the molar entropies of your reactants, is the next question is that how do you get these molar entropies? And so if we go back and think about how we defined the molar entropies, or not the molar enthalpies, for example, how do we find the standard molar enthalpy of formation? Um, we we talked about that in another video. So the standard molar of enthalpies of formation, and again, the symbol for change in enthalpy is delta H. Standard is represented by that circle right there. And the F here, the subscript F, is for the formation. So this is standard enthalpy of formation. Um, and then for elements, this is going to be for elements in their standard states. And so this, we define this as zero. So for enthalpies of formation for elements, those were in their standard states, those were considered zero enthalpy. And the reason we did that is because it was necessary, because there's no absolute value for enthalpies. We can't determine the absolute value of the enthalpy of any particular substance. So we had to define that the molar enthalpy of formation for elements was going to be in their standard states was going to be the zero standard that we were going to base everything else on, right? So we said that, okay, so we're going to say that the elements in their standard states, pure elements in their standard states, we're going to say, okay, they're zero enthalpy. And then when we do our reactions and we find energy changes, we can then say, well, okay, so since this is zero, so then everything based on that is going to have a value or enthalpy value based on that zero for elements in their standard states. However, we don't have to do that for entropy because there is an absolute value for entropy, and that's given to us in the third law of thermodynamics. And the third law of thermodynamics says that the entropy of a perfect crystal at absolute zero, which is 0 Kelvin, is zero. So that is what the zero entropy level is going to be. So we do have an absolute value of entropy, molar entropies. And so using that, we can base everything else, the entropy of other things or other substances based on the perfect crystal at 0 Kelvin. And why is it zero at zero? Why is it zero entropy for a crystal at 0 Kelvin? Well, that's because a perfect crystal at 0 Kelvin has only one way to arrange its components. And so if you go back to our definition of entropy, we said that entropy is measured by the Boltzmann constant multiplied by the natural log of W, and W was the number of ways in which your components can be arranged in energetically equivalent ways, right? So since there's only one way to arrange its components at 0 degrees of a perfect crystal, then W is 1, and the natural log of 1 is 0. So therefore, the entropy is equal to K times the natural log of 0. That's going to be 0. So therefore, you have zero entropy for a perfect crystal at 0 Kelvin. And so standard entropy values can be based off, is going to be 0. And so standard entropy values of other things are going to be based off that. So we have a standard, an absolute 0 standard. Okay, so another thing to keep in mind is that the standard entropy values are going to have units of joules per mole per Kelvin, right? and the per mole is in the unit there because entropy is an extensive property. And if you remember from your first year of chemistry, extensive properties are properties that do depend on the amount of substance you have. So, for example, remember, mass is an extensive property because the more substance you have, the more mass you have. Volume is an extensive property because the more stuff you have, the more substance you have, the more volume you have, right? So those are extensive properties as opposed to intensive properties, which don't depend on the amount of substance you have. For example, density. So density is going to be the same no matter how much of the substance you have. So if I have a pound of gold, that's going to have a density equal to a ton of gold. So density does not depend on the substance, the amount of substance you have. And so entropy is one of those extensive properties that does depend on uh, the amount of substance you have. And so there, ladies and gentlemen, is the standard molar entropies and how they relate to the third law of thermodynamics. I hope this was helpful. If you enjoyed this video and you learned something from this video, then please like this video. Please hit that like button right there. Please subscribe to my channel, hit that notification bell so you can be notified by other videos I put out. And also put a comment down in the comment section. Let me know what you think and if you've got any questions. Thanks for joining me and have a great day.